Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good evening. We are going to present our project, the automated fertigation system with hybrid solar and turbine power. This presentation would include the introduction, problem statement, methodology, innovation, result analysis, and the conclusion. Team members, we are from the Faculty of Electrical and Electronic Engineering UTHM, starting with our supervisor, Dr. Nabihah at Nabihah binti Ahmad, Muhammad Aliff Bazli bin Bukhari, Fatin Najiha binti Ahmad Kambali, Muhammad Faris bin Nordin, Leonardo Wong Yenn and me myself, Mazli Asmiza binti Abd Manaf. The introduction. A study in 2020 showing that more than 37.73% of the respondents had experienced income shocks due to COVID-19 pandemic, and most of them comes from the B40 groups. In 2019, contribution of 7.1% of gross domestic product (GDP) in agriculture sector has made the agriculture sector as one of the important sector in Malaysia. Modern agriculture like fertigation system could give a great and positive direction to improve the B40 income household. Energy harvesting by utilizing rainwater is suitable for Malaysia that has high annual rainfall. Thus, the application of solar and hydro turbine system is introduced.
According to our project, the problem statements are: first, most of the B40 groups depends on the plantation or farming because of undeveloped land still available. Second, farmers in B40 groups do not expose well to the modern technologies and most of them use traditional methods. Third, increasing population in Malaysia causing high electricity demand and cause to a decreasing of conventional energy. And lastly, the problem statement is B40 groups which depends on the agriculture sector consume high utility bills and it becomes a burden to them.
The objective of this project is to design an automated Chile's fertigation system to follow a schedule for water irrigation, to implement a fertigation system powered by clean energy and has an alternative power supply as backup, and number 3, to verify the functionality of the overall system.
So this is for the flowchart how the automated fertigation system is running. So I will explain part hydro turbine first. So basically, in this project we use two water tank that collect rainwater and flow into the pipeline with high velocity to move the turbine. For the turbine, we'll transform the potential energy and flow into the kinetic energy and convert into the electricity. So for the solar panel that collect the energy from the sun and convert into the electric power. Both of the renewable energy, which is hydro turbine and solar panel, will be connected to the charge controller and then connect to the battery bank. For the battery bank will be connected to the inverter and timer, and this is for the fertilizer timer. Fertilizer timer will be connected to the water tank, and then we move to the part operation. If the water pump is on, will be open and start the watering plant. If the switch not open, it means no watering plant at the day.
So today I will be presenting the design of automated fertigation system with hybrid solar and turbine power. As you can see here, there are two power sources that be power generation to the system, which are hybrid solar and hydro turbine. Starting from the hydro turbine, that generating the electricity through the turbine controller to giving an appropriate value to charge the battery. Same goes to the solar panels. They generate the electricity to charge the battery to the solar charger controller. We are using 12 VDC output power for hydro turbine and 400 watt for solar. The battery capacity is 115 Ah with 12.8 volts to store the energy. The inverter will convert. We are using the inverter that convert the electricity from DC to AC, follow to the AC load requirement. The size of the inverter is 400 watt. The function of the timer is to arrange a schedule in irrigating the plant. The timer will cut and on the power supply to the water pump, follow to the user setting. We are using 373 watt, which half horsepower for the water pump to irrigate the plant. There are 3 water tanks. The first one is to be a rain collector, and the second one is the rain water tank is used to store the water from the water turbine in using to irrigate the plant. The fertilizer tank is used to store the mixture fertilizer in a liquid form. The fertilizer timer will schedule the irrigation that ensure that the plant will get sufficient nutrients. For the innovation, we are selecting two renewable energy or clean energy sources. which are solar energy and hydro turbine energy, in giving electricity to the automated fertigation system.
And I'm going to present the result of MATLAB simulation. So the first one is the relationship between the irradiance, temperature, and the output of solar panel. Irradiance is manipulated from 1000 to below 400 over time, and the temperature is manipulated around 25 degrees Celsius to 50 degrees Celsius and fall back to 20 degrees Celsius. So we can notice that the output current of solar panel maintains constant, while the output voltage is decreased when the irradiance decrease, and the voltage increase when the irradiance increase. The voltage drop when the temperature increase, and the voltage rise when the temperature drop to 20 degrees Celsius. We can conclude that the power of the solar panel is equal to voltage multiplied by current. So when voltage is increased, the power is increased. Power output of solar panel is directly proportional to the voltage of the solar panel. The second result shows the measurement of the battery. So the battery is unloaded, disconnected the load, and the battery will be charged by our solar panel and hydro turbine. During the charging stage, the state of charge of battery is increased over time, and voltage of the battery is increased over time. The current of the battery increase in negative magnitude, which is below zero. This indicates that this is a charging state. The current flow into battery, so the current is in negative magnitude. The load is connected to the battery, and the DC supply of the battery is converted into AC before connected to our load, and this is the result. We can see that the output voltage is 242 watt PRMS, and we have a closer look. We can see that the voltage waveform is in sine wave, and it is suitable for the application. The frequency is 50 Hz. Thank you.
As the conclusion from our project, solar and hydro turbine able to generate power supply to the automated chiller fertigation system, so that this will help to boost E40 group's income, especially during this pandemic COVID-19. Next, the battery bank used as a backup supply in this system if the system is under maintenance or the energy supply from the renewable energy does not sufficient. And next, from this project, it will improve B40 group's technical skills and knowledge in the agriculture sector. And lastly, the recommendation from this project is to understand the implication of hydro turbine result is very important due to the limitation of hardware part that depends on the water availability. That's all from me, and thank you.